Welcome back. This is our second lesson on creating an internal Geneva mechanism. In a previous lesson, we converted our sketch entities to blocks and then learned how to convert them to parts. Let's see if we can do exactly that with these sketches. Let's insert a sketch on the top plane. Activate the rectangle tool. Drop it about here. Now with the square selected, let's go to the Tools menu, Blocks, and select Make. Accept, and exit the sketch. Now if I try to convert this block to a part with a right-click, we don't have that option available in the contextual menu. Let's right-click and delete Sketch 4. Yes, let's use a different method instead. We're going to insert a new part, Component, New Part. To align the part and the assembly orientation, I'm going to select the front plane. And let's cancel out. Do we want to discard everything? Okay. Since we selected the front plane first, our part is oriented the same way as the assembly. Let's insert a sketch on the top plane. Now I'm going to select Sketch 1 and click Convert Entities. Cancel out of the tool. The sketch is fully defined. Let's exit. And we're ready to create a solid. Go to the Features tab, Extruded Boss Base. Since our sketch was on the top plane, I'm going to extrude my solid so that it's located above the top plane. A 10mm extrusion should do it. And let's click OK. Now let's change the color. Right-click, Appearances. We'll change at the part level. Let's choose, let's say, red. Exit. And update. Now let's hide Sketch 1. Right-click, Hide Sketch. Next, we need to create the crank. Again, Insert, Component, New Part. Select the front plane to align the part with the assembly. Cancel out of the sketch. Do we want to discard? Yes. And let's insert a sketch on the top plane. Right-click, Insert Sketch. Select Sketch 2. And click Convert Entities. Sketch is fully defined. Let's cancel out of the tool. And let's exit the sketch. Now to the Features tab, Extruded Boss Base. I'm going to use the Selected Contours method. Let's activate the window and make our selections. Change the extrusion direction. Let's leave the depth at 10mm as well. And click Accept. Now let's hide Sketch 2 as well. Right-click and hide. Let's make this Sketch 2 visible. Select the sketch. Activate the Extruded Boss tool. We'll specify the contour again. And this one here. The pin needs to go in both directions. So for this reason, I'm going to use a mid-plane extrusion. Change the depth to 20mm. Merge Result is checked. And let's accept. Now let's right-click and hide Sketch 2. We'll change the color as well. I'll do it at the part level. Let's use a light blue. And accept. Exit the sketch. Lastly here, we need to create the base. So let's do that again. We'll go to Insert, Component, New Part. Once again, I'm going to select the front plane, cancel out of the sketch. OK. Let's insert a sketch on the top plane. Select Sketch 3, Convert Entities. Cancel out of the tool. Sketch is fully defined, so let's exit the sketch. And let's right-click on Sketch 3 and hide it. I've just moved to the Features tab. Let's activate the Extruded Boss Base command. And Selected Contours, let's activate the selection window. Take our contours. For this extrusion, I need to go 10mm above the sketch plane and 10mm below. So let's use a mid-plane extrusion. 20mm for the depth. Accept. Let's create a second extrusion now. Right-click, make sketch visible. Once again, let's pre-select the sketch. Extruded boss. Let's select our regions now. This extrusion needs to go below the crank. To achieve this, I'm going to use the offset option. Let's enter an offset distance of 10 millimeters. Click here to reverse the direction. Here the offset will also be 10 millimeters, reverse the direction. Merge result is checked, let's accept. Lastly here, we need to extrude the pin where the crank will rest. Let's select Sketch 2, Extrude. Select this region. Let's reverse the extrusion direction. 20 millimeters is fine, accept. Now let's hide Sketch 2. Right-click and change the color. We'll do it at the part level again. Let's use dark yellow, for example. Click Accept. Okay, let's exit and rebuild. And let's save our assembly as well. Parts 1, 2, and 3 are internal to the assembly. Let's save all. Save internally, OK. Now if I try to move my components, it won't happen because we've got 3 in-place mates in the Mates folder. In order to test our mechanism, we're going to need to apply different mates. The first thing to do is add a fixed relation. Let's go to the Assembly tab. The most logical part for a fixed relation is the base, of course. However, watch what happens when I add the fixed relation to in-place mate 3. Let's right-click on it. Select Fix. Notice that in-place mate 3 becomes suppressed. Let's select mates 1 and 2. Now we're ready to apply mates. Let's deselect everything. Select the Mate tool. This edge and this edge coincident. One more coincident mate. This edge and this edge, OK. And cancel out of the tool. Now if I try to move my components, it still doesn't work, so let's figure out how we can make them work. The first thing we're going to do is align the components in the approximate correct position. In my case, the slot needs to be located in a way such that the pin can enter it. Let's activate the Move Component tool. Options, Physical Dynamics. Now let's test our mechanism. Looks like it works just fine. If I didn't have the components in the correct starting position, watch what would have happened. Okay. Now you may be wondering why I simply didn't delete the in-place mates, but I've suppressed them instead. We're going to learn about this in our next lesson. And this concludes our project on the internal Geneva mechanism.